Hello, I'm James Sylvester from JPS Reliability. Firstly, apologies for it being so many months since we followed up on our last case study 4. This is case study 5 from the Book of Gold, and this is done with support of RMS training. Just to recap about JPS Reliability, we're a team of specialised practical condition monitoring technicians, engineers, and what we do is we work to enhance system reliability by applying condition monitoring, which then improves the machine functionability. But to do that, if you don't understand how your system works and how it can fail, you won't know the failure modes to monitor. So we determine the failure nodes through our experience. And likewise with condition monitoring technologies, there's a few about. And if you don't know which technology is best to pick up the failure mode at the correct interval for yourself, then you could be applying vibration, thermal, ultrasound, oils all incorrectly and thinking it doesn't work. It does work when it's done correctly. So we enhance system reliability, improve machine functionality, we determine the failure mode, apply the correct technologies, and through that we then advise and help the maintenance do the correct maintenance tasks to ensure the asset runs longer or eliminate repeating effects. Because as we know, condition monitoring alone does not improve reliability. You have to take actions to eliminate and engineer out repeat failures. A little bit more about us. We've got over 40 years experience in condition monitoring, balancing, alignment, reliability engineering. We work with many of the blue chip companies in US, UK, Canada and Australia. We cover all the technologies. We don't particularly like one, we love them all and we work with them all. From thermal imaging, vibration analysis, ultrasound, NDT, planning, improvements, all the way through to balancing and laser alignment. We're also certified in the said technologies, registered with lots of engineering councils as well, safe contractor and safe PPQ certified. But more important, what we're very proud of is the books we published. So the first book we did, this was basically 20 years of my black book notes. So I used to write down what I couldn't understand and I put it into this book here. This is Enhancing System Reliability Through Vibration Technology. It starts with covering condition-based maintenance, condition and monitoring maintenance practices and processes. Then the bulk of it is actually on vibration analysis. It's taken it more to a technician's level so we can understand it and work with it better. And at the end we got balancing an appendix and a big chapter on case studies. Now this book actually was a driver to our Book of Gold because this book was distributed all over the world, had really great feedback, and what people loved about it the best was the case studies. So myself and James Pearce decided, well, there's nothing in the market in the whole world which has got case studies from VA data to images of bearings stripped down to the failure mode. And lucky enough, we like to keep things in its place. I wouldn't say we got OCD, but we want things done right. So we've always archived and kept history. So that made it quite easy for us to print and produce the JPS Reliability Book of Gold. So we've got a dust cover. Inside it's black cloth. So we've got black cloth, gold inlay writing. We've printed it on the thickest paper we could. And it's on shiny paper, so it could be wiped clean in case you're using the workshop. So we've got stripped down reports, vibration analysis. This can be used for reliability engineers and vibration technicians. What good is filling the gap from the body of knowledge. So you can do your course, your ISO course, get certified level 1, 2 and 3, and you may work at a factory for 10 years. Then you got 10 years of 1 year's experience 10 times because you haven't had the opportunity to work around all different places. But lucky enough, me and James have. So we worked around all these places and we learnt lots, and this book is all our case studies put together to help everyone bridge that gap. So you can look on our website and also the RMS training website, and you'll have our previous case studies, and also we got a lot on enhancing system reliability. So this one is case study number 5, and this is enhancing, well, using SPM HD enveloping on the fan motor. Just to highlight how proud we are of our books. Thanks to poor RMS, we've been tracking the location of where our books are distributed, and you can see the gold colour ones is Book of Gold and the blue is Enhancing System Reliability. So we're very proud that we managed to get our books out all over the world, and we got distributors in the UK, Africa, USA, Australia, Europe who are helping us get the book out because it's very niche. Back to the case study. So this one here is a process fan in a production facility. So you've got your motor, your joy belts going up to your fan on your pedestal, and it's just circulating air fan. So it's a clean air fan. It should run forever. But this case study is really good, how it shows that even using trend as your friend, you can pick out when to change that out at the opportune moment so the fan doesn't break during production. And then the reliability loop of it is, why did it fail? Was it age related? Can we prevent it from failure? And you try and eliminate it. So as part of the routine program, they detected it, and then there was a slight increase in the levels. So rightly, they increased the amount of time and reduced the time, between monitoring intervals. This here is a very simple plot of the acceleration RMS. We produce peak to peak, but on this particular trend, we have the RMS. And you can see it steady, up, bit of grease and came down, up. And at the very end, all the black dots is where the chap was taking the data more. And it's starting to exponentially go up. Looking at the SVM HD enveloping, this is really good and it's very crisp and clear. So we could see a nice clear signal at 3.09 orders, which is the outer raceway, and lots of harmonics. When you do analysis, as a chap in Australia said to me, you got to get your life in order. You analyze in orders. Me personally, I flip between hertz and orders, because hertz you can pick up your electrical frequencies quite easy, and you know what's rotor bar and your drive frequencies. But in orders, a bearing going 2 RPM is always going to be 3.09 orders defect. If it's going 1000 RPM, it's 3.09 orders. The order doesn't change, whereas CPM, RPM does. So if you get your life in orders, you can easily pick out outer race, inner race, ball spin, without even knowing the bearing defect or the bearing part number in it. So this very short presentation shows you that just monitoring the trend and the orders, we could pick out a clear outer race defect. And these levels would confirm a spalling in the inner raceway. So that to reduce the risk of failure, they got a new motor and they placed it on site in the area which was subject to the environment, kept it away from vibration, and waited. They had a shutdown on the line for another job, and they changed the motor out. So we managed to change the motor in the stoppage. So it didn't stop the plant, didn't cause any failures. And what you must do when you do this is go back afterwards and see, has it improved? Well, the top plot is with the bearing defect, and the bottom plot, no bearing defect. So you can say the new motor is commissioned, installed, and it's running good. This is a trend, so we can see the levels have actually come down lower than what they ever historically have been. So we've got the old motor going up, the extra dots where we're sampling even more, and then boom, down when the bearing was changed. So on bearing inspection, what we actually found was a spalled area on the bearing. We did say, how long has the motor been in? No one knew. They all thought it was the original motor, been in there for years, and it's just ran, because it's a nice clean air fan. And when you're actually looking closer on the bearing inspection, we could see here, you can see the spalled area, the direction of rotation, and the overall then of the damage. And you can actually sort of see some cracks. So when we looked into it, what was the most probable cause of failure, which is very, very rare, is age-related failure, subsurface initiated fatigue. So this motor had been there for so long, maintained good, but it's just reached its cyclic life and it needed changing. So this is another great example of how this technology, knowing your system, the risks to the plant, you can use control maintenance. And in this particular case, we can't improve reliability as such because it is end of life of the bearing. But if you do get a defect, you need to work out why it happened and can you prevent it from happening. So this is the Book of Gold, just summarising a bit about it. And these are our current suppliers across the globe. Basically, we've got UKR, which is main RMS. Australasia, we have a chap in Australia who's got copies in stock. So if you're in Australia, give us a shout and we'll get it over to you. Latin America, Colombia, Europe, Iraq, and certain parts of Africa, West Africa, South Africa, Frederick covers. That's our ISNBN number, it's just all registered. And also, if you do sit the RMS VCAT 2 courses, public courses, they're that good and they want improved training so much that you actually get the Book of Gold free with your course material. So when you do leave the course, you know the body of knowledge and you've got a really good book with case studies and histories to help you improve as you go along. Short but sweet presentation. We wanted to get another one out there because it's been a fair few months. Anyway, do take care. Bye for now.